Hello, algebra students. Mr. Lawrence here, and here's your Chapter 6 review video. All right, first of all, Chapter 6 is all about solving systems of equations and inequalities. First thing I'm going to do is I'm going to solve by graphing. So I've got two equations here, and if I want to solve them by graphing, they're linear equations. I'm trying to find out the place where the two lines cross. Well, the first line, and I'll put a red point by it here, red bullet. The first line is in slope-intercept form, so I just simply plot the y-intercept, and my slope is 1 over 1, right? And then I can draw my line, and I'm going to take my time and do the best I can. And let's see, I want to make sure that's actually a line there. This should be total review. This kind of stuff should be simple. So let me get an arrowhead on the start, and let me put him on a diet. And that's not too shabby. I might need to clean him up a little bit there. Make sure he's going through the actual points. All right, the second point is in standard form, and in the Chapter 5 video, I talked about the standard form shortcuts. I think I'm going to find the y-intercept of this one, and the y-intercept, I believe, is going to occur at 0. And then c over b, so it's going to be at -2, right? Because c is 2 and b is -1. So there's my y-intercept. I'm not going to go looking for the x-intercept. Instead, I'm going to use the slope, because I think it'll be easier, and I'm going to do the negative of a over b, or better yet, 3 over 1. So I'm going to rise 1, 2, 3, and run 1. And I'm going to rise 1, 2, 3, and run 1. And look at that. I found out where they cross. Okay, so the solution to the set is going to be the point 2, 4, right? And then I should draw the line in. Oops, I ran off my airliner there. Sorry about that. And so you can see that they are crossing at the point 2, 4. All right, so that's done, and that's solving by graphing. I'm not planning on doing any more examples of that. Let's get on to the next point. All right, the next one is solving by substitution. Now remember, in substitution, you need to have one of the variables by itself. Some of you are such slaves to habit that you always solve for x in the first equation or always for y in the second equation. I think that's foolish. I would look at the coefficients of x and y in both equations and decide which one is the least amount of work to solve for. And in this problem, I think y in the second equation will be the least amount of work. So I'm going to go ahead and solve for y in the second equation by adding 2x to each side. And so I'm going to get y equals, and you can write two things. You could write -3 plus 2x, or you could write 2x minus 3. Now I'm going to rewrite the first equation, 4x plus 3, but instead of writing a y there, I'm going to write what y equals, 2x minus 3. That's going to equal 14. All right, so got to do a little simplifying on the left-hand side. I'm going to distribute here, right? So I'm going to get a plus 6x minus 9. That's going to equal 14. So 10x is going to equal 23, I believe. So x is going to be 2 3/10. 2 3/10. Now, to figure out y, I'm going to use this equation here where y is already alone. So I'm going to go y equals 2 times 2 3/10 minus 3. Well, I think that means y is going to equal 4 6/10 minus 3, or better yet, y will equal 1 6/10. So these two lines will cross at the point 2 3/10, and then 1 6/10. All right. Now, one thing I should point out is when we go to solve a system, there's three possibilities of what might happen. We might get one solution, right? One solution, like we did in the past two problems. We might get no solution. And the way you'll know no solution is if you're graphing, the lines will be parallel. They'll never intersect. If you're solving it algebraically using substitution or elimination, you'll get something like, 5 equal to 7, a statement that is never true. If you get a statement that is never true, all your variables drop out, you know that the lines are parallel. Now, if you wanted to, you could go check the slopes. Yeah, you could go check the slopes of the lines and make sure they're parallel. Remember that parallel lines have the same slope. All right, and finally, there could be infinite solutions. In that situation, you would graph the same line on top of itself. So in other words, the two lines would intersect everywhere. They're actually the same line. You might get a situation like 3 equals 3 if you were doing it algebraically, right? It's always true. You can check the slopes. You get the same exact slope. Check the y-intercepts. You know that they were parallel. You know that they're the same line if the y-intercepts are the same. All right, so that's substitution. Elimination. Now, elimination is my least favorite, but it's a good way to do it sometimes. In elimination, I want to make it so that two of my coefficients are negatives of each other. Like if I had an x plus 5y and an x minus 5y, I'd really like that because of the plus 5y and a minus 5y. Sometimes it's already set up like that. In this problem, it's not. But if I look, I have a couple different choices here. I could decide to eliminate my x's, in which case I'd probably multiply the top equation by 7 and the bottom equation by 2. Or I could eliminate my y's. And if I do that, which I think I'm going to do, I'm not going to multiply the top equation by anything. I'm going to multiply the bottom equation by 3. Why 3? Because 3 times negative 5y will give me a negative 15y. If I multiplied it and got a positive 5y, then I would want to use, or positive 15y, then I'd want to multiply by a negative 3. But in this case, I'm okay. So, using the positive 3. So I'm going to have a negative 2x plus 15y, and that's going to equal negative 32. And then the equation that I manipulated, that I changed the way it looked, is going to be 21x minus 15y equals 51, I believe. Yeah. All right. So now to do elimination, I'm just going to add them together. So I'm going to get a 19x, and that's going to equal, let's see, 52 would be 20. It's going to be 19. I think it is. I think negative 32 plus 51 is 19. Solving for x yields the answer x equals 1. All right, now to find y, I'm going to plug it into one of these two equations. I think I'll plug it into the first one. So 7 times 1 minus 5y equals 17. So that will tell me that negative 5y equals 10, right? I multiplied 7 times 1 and subtracted 7 from both sides. Now I divide by negative 5, and y is going to equal negative 2. So the point 1, negative 2 is there. All right, so I just solved one by graphing, one by substitution, and one by elimination. Now, sometimes we have to solve systems of linear inequalities, and the only way we've done this so far is to do it using graphing. So I'm going to go ahead and graph, and I've got y is less than 2x minus 3. Well, that looks like slope-intercept form, kind of. And so I'm going to get a negative 3 as my y-intercept, 0, negative 3. My slope is 2 over 1. And remember, it's not equal to, this is something some of you have forgotten, it's not equal to, so I am going to have a broken line. Lost my line there, where'd it go? All right, so I'm going to have a broken line. I'm going to have to make him thinner and get him lined up better. He doesn't look very good at the moment. All right. Make him nice and thin. I don't need to put an arrowhead on him because it's already there. Okay, I'm not sure where they're actually going to overlap. Now, there's another thing I have to do. I have to check for shading, right? Because the inequality always has shading in it. So I'm going to put a test point. And since the line is not going through the origin, I'm going to use it as my test point. So y is 0 is less than 2 times 0 minus 3. So that means 0 is less than negative 3, which is a false statement. Not true. So I am going to shade the other side of the line. I'm going to shade this side over here. I didn't shade the origin side of the line because when I plugged in the origin, I got a false statement. Now I could plug in any line that I want, or excuse me, any point that I want. The origin just makes the math easy. So I could have plugged in 2, 5 or 0, 10 or anything like that. I like to use the origin because it makes it simple. Now, by the way, I can't use the origin if the line is going through the origin. Then I have to pick a different point. Okay, so let's try this one. It kind of looks like standard form. I think the x-intercept is going to be 1, and the y-intercept is going to be 2. So it looks like my slope is negative 2, so let me do that. And this is going to be a solid line. How do I know? Because it says equals to. Yeah, it's going to be a solid line. It says equals to. All right, so I'm going to go like, let's get this lined up here. All right, got a solid line instead of a broken one. Broken ones only apply when it's just less than or just greater than. If you say equals or equal to or something like that, then it's going to be a solid line. So let me give him on a diet, not a date, excuse me, and do that. All right, so now my test point. Can I use the origin? I sure can. I'm going to test with the origin. I'm going to go 2 times 0 plus 0 is greater than or equal to 2, right? 0 is greater than or equal to 2, which is not true. So again, I will not shade the origin side of the line. I will shade the other side of the line. So I'm going to shade over here. And the solution is where the two areas got shaded twice. How can you tell where it got shaded twice? Well, yellow and blue make green, right? Okay, so it'll look something like that. And this is really hard to do because the airliner is just acting up something fierce. Look at that, I just turned on a Wi-Fi password. I have no idea how. All right. Nothing confidential came up. All right, there you go. Okay, so that's solving inequalities. Now, let's see what else we have here. Oh, application problems. Can't forget those. A boat travels downstream at a distance of 200 miles in 4 hours. The return trip takes 6 hours. Write and solve a system of linear equations to determine the speed of the boat and the speed of the current. Well, first of all, I'm going to let b equal the speed of the boat. And I'm going to let c equal the speed of the current. All right, so when I'm going downstream, that's the boat plus the current, right? Because the current's pushing me along. When I'm going upstream, it's the boat minus the current. Now I have a speed plus a speed. That has to equal speed. But they didn't give me a speed. They gave me a distance and a time. Well, doesn't speed equal distance divided by time? All right, well, the distance is 200. And the time downstream is 4 hours. And then on this one, the distance is 200. And the time is 6 hours. So, simplifying those fractions, I got b plus c equals 50. And then I have b minus c, and that's going to equal like 36. 6.6 repeating, is that right? 200 divided by 6, 33.3 repeating, 33 and a third, right? I'm going to go like that, 1/3. That'll make it easier. All right, now I'm going to use elimination. This is a situation where I really like to use elimination, because when I add it together, I'm going to get 2b, and that's going to equal 83 and 1/3. So I'm going to divide that by 2 to get b alone, and I'm going to get the speed of the boat is 41 2/3 miles per hour. To get the speed of the current, all I'm going to do is 41 2/3 plus c is going to equal 50. I'll get c alone, and I think I'm going to get 8 1/3. I think that's right. Yeah, 49 and then 1 miles per hour. There you go. Pretty simple stuff. All right. Let's see. I think I have another problem down here. There it is. Dr. Kaboom needs to make 200 liters of a solution that is 35% acid. He has 2 vats of acid on hand. One is 50% acid and one is 30% acid. How many liters from each vat should he mix together to create the desired solution? Well, let's see here. First off, I'm going to let X equal the liters from 50% vat, and then Y is going to equal the liters from the 30% vat. Now this is where some of you would make a table. I'm not going to make the table in here, because if you know how to make a table, you probably remember. So I'm just going to go ahead and set up my 2 equations. So first off, I know that if I mix some from X and some from Y, the total must be 200. Now, the amount of acid, well, I would take the percentage of acid and multiply it by the liters from acid. Liters from the vat, excuse me. Then I'm going to take 30%, which is the percentage of the acid, multiplied by the liters. And then I've got to do it here. I've got to take 35% and multiply it by 200. So this is going to give me the actual liters that are acidic from each vat. Okay, obviously vat A is a stronger acid. So I think I'm going to simplify that. Let me see here. 10% of 200 is 20. So 30% is 60. 5%, I think this comes out to be 65. Right? Now, I think I'm going to do substitution. So I'm going to solve, I think, for x. X is going to equal 200 minus y. So I'm going to come down here and go 50 hundredths times 200 minus y plus 30 hundredths y. That's going to equal 65. Okay. That's going to be 100 minus 5/10 y plus 3/10 y equals 65. And so if I subtract 100 from both sides and combine the like terms, I'm going to negative 2/10 y equals 35. Oh, I have a mistake. Oh, negative 35. Good. I like that. And then I can divide by 2/10, or I could multiply by 5, negative 5. That would do the same thing. All right. Dividing by a negative. And so y, excuse me, is going to equal 175 liters. To get x, I'm going to take x plus y equals 200, subtract off y's value, and I'll get 25 liters. Yeah, there's the story problems. Okay, let me see. Is that it for the video? I think that might be. That's all I had intended for Chapter 6. If you need more practice, please come in for help. Please check out study guides, all that kind of stuff. All right, Mr. Lawrence signing off. Have a good night, everybody.